Derivative is slope. Slope is derivative. Today is more about graphs and tables, so less equations, which in some ways is good because you don't have to remember how to do product rule, quotient rule, trig rules, power rules. You don't need any of those rules. It's all, and this may be good or bad, it's all concept. Like slope is derivative. So let's consider this function whose graph is given below. At how many values between a and b is f prime equal to 0? F prime meaning slope of the tangent line. So how many places would have a tangent line slope of 0? 4. 4. At all the maxes and mins. Well, actually I shouldn't say that because there's a min down there, but it doesn't even have a tangent line. So yes, 4 places have a tangent line whose slope is 0. Question B, how many values between a and b is f prime non-existent? So how many places between a and b is the derivative non-existent? 1. And which point are you looking at? O at the origin there. And why is it non-existent there? Because it's a cusp. Part C. How many times between a and b does the sign of f prime change? Okay, f prime is like the slope. So what it's asking is how many times does the slope, or how many times does the sign of slope change? 6. So this one's a little bit harder. Let me see here. So negative to positive, there's 1. It changes there. Positive to negative, it changes there. At the origin where we circled, it doesn't have a derivative, but the slope changes. So that's a third spot. 4 and 5. So I think 5 times it changes. All right, another picture. Consider the function f is given, graph is here. Which of the following is true? F prime at all these different spots. But what is f prime telling us about a graph? What is f prime? What's the word that goes with derivative? Slope. Slope of a tangent line. Alan, did you have a question?
Yeah, I wanted to ask, let's see, one again. So a little, like the cusp area, would that just count as 1?
It counts as 1 because it's changing from negative to positive. So this really just means the slope at negative 1 compared to the slope at 4 compared to the slope at negative 3. So we've got all these different values. The slope at negative 1 would be negative 1/2. Right, this is just like algebra 1. I mean, it's calculus words, but it's algebra 1 concepts. F prime at 4. 1, 2, 3, 4. So that slope is, change in y is negative 6. Change in x is 6. So that slope's negative 1. So already we're not right. Right? Negative 1/2 is not less than negative 1. So that one's out. F prime at 1. I should start labeling these. That slope is up 1 over 1. So that slope is 1. F of 1. Oh, be careful. So not the slope at 1, but the value of the function at 1, which should be 2, is less than the value of the function at 3. So not the slope at 3, but the function value at 1, 2, 3 is, I think, 2. So that's close to true, but I don't think that's true because it doesn't have an equal sign there. So I'm going to put a question mark on that one. Maybe, if I'm not reading my graph right, I can come back to it. F of 5, 1, 2, 3, 4, 5 is 0. F prime at 1 is 1, and f prime at -4, 1, 2, 3, 4, the slope of this line, that looks to be more than 1. That's a steep slope. That's up 6 over 3, so that slope is 2. So it's C. Nothing new, just slow down and understand what they're asking for. Part B, if h of x is 2x times f of x, so what rule are we going to have to use here? 2x times f of x. That would be the product rule. I should be very careful about labeling these f and g. I certainly don't want to label the first one f and the second one g, because then I'm really confused on who's who. I think I'll just try to do it in place, because I know that the product rule is one of them times the derivative of the other. So 2x times f prime plus the other way around, f of x times 2. First one times derivative of the second plus second times the derivative of the first. And then h prime at -4 means plug in -4 for x and see what happens. There was a couple problems kind of like this on the last test. So let's see, -8 times f prime at -4. That would be this slope, which we already found out was 2. F of -4 is -2 times 2. So -16 minus 4 is -20. Like I said, nothing new today, just more practice on the stuff that we sort of already know. Hopefully already know. Number 3. Or let's back up a second. So we've got a table of values where we have f and g and f prime and g prime. Yeah, there was definitely something kind of like this on the test. If h of x is f minus 3g, then h prime would be f prime minus 3g prime. And then at 5 means we plug in 5 to all those places. So at x equals 5. Just tight on space here. So f prime at 5, as I grab the popsicle sticks, because we're just reading the table now, hopefully reading the right spots. Well, Addie, welcome back. You haven't been here in a while, but I bet you can tell me from the table what's f prime at 5? 2. And then Bryce, what's g prime at 5? -0.5. And then this is a free response question, so that is a safe stop, and we can leave it like that. What rule are we going to have to use on letter B? Product rule. And they were kind enough to give us f and g, so this will be kind of easy. They're labeled the right way. So 2f g prime plus 2gf prime. And all of those at 5. So looks like we'll use everything. I just got to put them in the right spot. So f is 6. G prime is -1/2. G is -4. And f prime is 2. And again, it's a free response question, so you could just leave it like that. Negative 6 plus negative 16 would be negative 22, but don't do that unless you need to. What are you going to need for C? Quotient rule. So why don't you try C? So, quotient rule, plug in the values, and then be done. Unless it's multiple choice, then you'd have to clean it up. What's going on in letter D? Chain rule. Okay, so chain rule is outside in. So first the derivative of f, leave g alone, times, now we work our way in, the derivative of g, leave x alone. And then you can't go one more because the derivative of x is 1. So if you really want to like chain rule it all the way down, you could have a times 1 at the end of there. Alright, plugging in 5 is a little trickier because of this nested stuff. So g of 5 times g prime of 5. So f prime of, so Jace, what's g of 5? So I want the value of g at 5. Negative 4. And then g prime of 5 is negative 1/2. And what about f prime at negative 4? I think somebody left some information off our table. What's that? Oh, right here, yes, there we go. Read the question. F prime at negative 4 is 7, which seemed weird. Why is that even in there? But now I know why it's in there, because we needed it. So 7 times negative 1/2, and that's our answer. Again, we kind of know how to do that already, but more practice. Let's see. We want to do number 4. It looks kind of like what we just did, because I see chain rule, quotient rule, chain rule, some new rule, and then one value in the interval. That sounds like intermediate value theorem. Let's skip number 4. That's we've done all that. Let's jump to number 5. The graph of the function g is shown on the right. If f is the function given by g of x, what is the value of f prime of 4? So I need f prime. What rule is going to be in play here if f is g of x? That's the chain rule again. So the outermost g prime at g of x, times the derivative of the inside function, g prime of x, times the derivative of x, which is just 1. And then we want to find that at 4. G prime at g of 4 times g prime at 4. Alright, I'm going to pause it again and let you. So you started with g of 4 is 2. You have to find that. And g prime at 4 is negative 1, the slope of that line. And then g prime at 2, also negative 1, and negative 1 times negative 1 is 1. So a little bit of calculus, a little bit of algebra. Maybe a medium amount of both. Okay, kind of the same thing. The graph of the function g is shown on the right. That's the same graph, so all those, I'm going to label those right now. That slope's -1, this slope's 2. Might need that. If the function f is g of x, what is the value of f prime at -1? Okay, so almost the same thing. Why don't you try number 6? So again, when you hit a derivative at a cusp, you're kind of done with the problem. You can't do that. Uh-oh. Number 7, the table on the right. Again, a table problem. Wow, look at this thing. What rule is at play here? I want to say product rule as well, because you got that and that. And I don't want to label them F and G, because F and G are within what I would label F and G, so that would get kind of confusing. So instead, let's just try to do it on the fly here. So the first times the derivative of the second. So 3f of x minus 1 times, what's the derivative of the second? What's the derivative of all that? Just g prime of x. The derivative of 2 is 0, so that just leaves g prime of x. Plus the other way around, so the second, 2 plus g of x, times the derivative of the first. What's the derivative of the first? Yeah, 3 times the derivative of f. 3f prime of x. And so if we want h prime at 1, we got to plug all those pieces in. 3f of 1 minus 1 times g prime of 1. I suppose you could substitute and go to the table kind of all at once if you didn't want to write all this down. Let's see, so 3f of 1, so that's 9 minus 1. G prime at 1 is 4. G of 1 is -3. Plus 2 is -1. F prime at 1 is -2. So 8 times 4 is 32. Although that is a safe stop. Once you've plugged in, it's a safe stop. You can't leave f of 1 and g of 1. You've got to plug things in. But once they're plugged in, you're good. 32 plus 6 is 38. Number 8 looks like what we've been doing, but there's a couple of twists in there. So let's do at least A and B of number 8. Again, a table. This time our table has not just f and f prime, but also has f double prime. So a second derivative showing up in here. So part A. What are we going to need for part A to find the derivative of h? What rule are we using here for f of 2x? That's going to be a chain rule. So outside in, the derivative of f is f prime. But it's not just f prime of 2x. What do I need on the end of that? A 2. A chain rule thing. Times 2. Plus, and then kind of the same thing. G prime. Leave the inside alone. And then what's chained onto this one? 2x. The derivative of the inside is 2x. Our calculus is done, and now it's time to see how our algebra is to find h prime at 3. So that's f prime at 6 times 2 plus g prime at 3 squared is 9 minus 3 is 6 times 6. And then it's just going to the table, and hey, what do you know? The table has exactly what I need. F prime at 6 is -3. And G prime at 6 is 2. And then that would be a safe stop because we filled in everything. Negative 6 plus 12 would be positive 6. All right, the one I was hoping we'd have time to get to. What rule is going to be needed here for part B? Definitely the quotient rule. And we better be careful. Usually I just label the top F and the bottom G and find F prime and G prime. But man, that's going to be kind of wacky because then I'd be labeling G as F and labeling F prime as G. And yeah, so I need to figure out what H prime. I'm going to write it out to the side. G F prime minus F G prime over G squared. This is where it might have been helpful if you memorized it the other way. Low D high minus high D low over low squared. So I've got to apply this to G and F where things are backwards. So goodness. Okay, so G F prime. So that's the bottom one. So what's playing the role of G in this function? 2F prime. So G is 2F prime. And then I need F prime. That's the derivative of the top. What's the derivative of the top? G prime. So yeah, this is really annoying that they assigned these variables to this, given how we memorized the formula. Minus F, that's the top. What's the top? G of X. G prime is the derivative of the bottom. So what's the derivative of the bottom? 2F double prime. And then squaring the bottom, that would be, well, I'm just trying to decide, do I want to square the whole thing or do I want to go ahead and square the 2 and get 4 F prime of X squared. Again, nothing new today. It's just, do you understand quotient rule well enough to apply it where they're intentionally using the letters that you memorized to try to jack with you? From here, it's just plugging things in. So 2. Do you want to try to do this kind of on the fly? So F prime at 6. So I can go to my table. F prime at 6 is negative 3. G prime at 6 is 2. G of 6 is negative 2 times 2. F double prime at 6 is 3 all over F prime at 6 is negative 3 and then square it. And then safe stop so you don't mess up anything else. Signs and numbers and whatever. And then H is, the last one is kind of the same thing. Be very careful about who's the top, who's the bottom. You're going to have a lot of second derivatives show up and first derivatives, so yeah, that's going to be kind of wacky. All right, so your assignment's worksheet 1. Nothing new, just apply.